right. Thank you, Dr. Bose. Good evening, trustees. We're proud to bring before you tonight our recommendation for the Next Generation Science Standards, or NGSS, curriculum adoption. This is the culmination of over a year's worth of work and a truly practitioner-led effort by our elementary and junior high school teachers, all of whom have demonstrated collaboration, coherence, and ultimately consensus. Before we jump into this, I think it's really important that we bring several recognitions to you in this work. First and foremost, Ingrid Salim, our NGSS coordinator and elementary science teacher and junior high science teacher, did a fantastic and amazing job leading, orchestrating, mediating, and facilitating much of this work over the last year. We're grateful to have her representing our science program here in Davis Joint Unified. Also, shout out to Ken McKim, science teacher at Harper Junior High, whose knowledge of the curriculum and publishers worked out the best arrangement possible for our 7th and 8th materials recommendation. And then, of course, our very own secondary director, Troy Allen, who oversaw this process, supported our teachers along the way, and will now present our recommendation. Director Allen.
Good evening. Thank you. Roddy, we can move to the next slide. I would like to reiterate a personal thank you to all the teaching staff that engaged so deeply and thoughtfully in this work. This is one patient crew, given the span of time that it's taken us to move to this process tonight. I want to remind you that in February, we shared an adoption update with you that gave a detailed summary of the history of Next Generation Science Standards and specifically DJUSD's work. And in short, what happened is in 2013, the California State Board of Education adopted the Next Generation Science Standards, which launched us into a multi-year approach, both as staff and teachers. The new standards include what the students should know, and that means the disciplinary core ideas, and those are things like matter, energy, ecosystems. It includes what students should do, and that is using scientific and engineering practices, which is a fundamental shift. And it also identified cross-cutting themes that connect different domains of science. So an example of cross-cutting themes are like scale, systems, patterns, things like that. These themes exist in earth science or biology or chemistry or any science class that you can really think of. And in elementary school, we may ask students to notice, as an example, if we were talking about patterns, the patterns that they see in nature or can easily identify. And as kids move through the upper grades, they may be seeking patterns that they actually need mathematical equations to identify and make sense of. But those cross-cutting themes start at the earliest science education and take them through the most advanced. So you can see that with those significant shifts that we had to put a fundamental focus on understanding standards and the frameworks through professional growth. And that was the critical work that happened from 2013 to recent. But what it also did is it means that our 4th through 8th grade teachers and staff that are bringing you this recommendation hold a deep knowledge for the framework and the standards that inform an adoption and the choice of the materials that support it best. Next slide. So as we start thinking about the process that the staff went through, the science teachers in the 4th through 8th grades participated in a very collaborative process to identify materials for pilot in the first place. They had to whittle down like a lot of options. The 2 programs that were identified for pilot in the elementary were Amplify and National Geographic. The 3 programs that were identified for pilot for grades 7 and 8 were Lab Aids, Discovery, and Amplify. And almost every DJUSD elementary school, our science teacher participated in the pilot, and all 15 of our middle school teachers participated. Teachers held deep conversations with students about students' opinions on the ease of use, whether the students felt engaged and challenged. They compared the pilot materials. The teachers came together repeatedly with an agreed upon rubric to evaluate the publisher materials, and they piloted the entirety of the school year to acquaint themselves and to gauge both student experiences and the outcomes that they were seeking. These same teachers met with frequency that culminated in May with every teacher that piloted present to come to the final adoption consensus meeting, and that's the data that I'm about to show you. I'd like to reiterate that we hold a deep gratitude for Ingrid Salim for her leadership and her just tireless work over a span of years to get us to the point where we were able to come to consensus and better understand the work that we were doing. And also to Ken McKim for his recent negotiations that will inform the professional development that we'll be engaging in the future. So with a little drum roll here, the DJUSD 4th through 6th grade science teachers decided almost unanimously to adopt Amplify. And the strengths of the program include a strong storyline, what they consider to be excellent digital simulations and modeling, as well as challenging writing and thinking prompts. Teachers recommend that Amplify be supplemented with hands-on phenomena for the very best student experience. And this program would translate successfully to distance learning. The adoption includes mostly digital resources through an online platform, and then small books to support each unit are included in the purchase. The 7th and 8th grade teachers agreed almost universally on lab aids, and the strengths of the program for them included strong hands-on and phenomena-based lessons, challenging writing and thinking prompts that use the language of the discipline, and a flexibility to allow for teacher differentiation. The science teaching staff note that the labs and the hands-on emphasis lend itself to traditional and in-person instruction. So as you know, the adoption cycle spans 8 years, but our history has taught us that we often have the materials that we adopt or we purchase and adopt much longer. In fact, our last science adoption took place in 2008. So this is because adopting a state framework and standards doesn't necessarily mean that the state is able to provide us money in order to make purchases for new adoptions. In this case, we will use the restricted lottery funds, which are designated solely for instructional materials purchase in order to make the one-time purchase. And the total price tag allows us to secure both the curriculum for students and teacher materials on all sites, including Da Vinci Junior High and DSIS, using projected enrollment numbers. And that bottom line comes down to $512,899. As we looked at that price tag, especially in our current landscape, I do want you to know that we did the math and we figured it out how many students that would impact over a period of 7 years. And what we learned is for $22.68 a student, we will be able to take care of our 4th through 8th grade students with this science adoption. Next slide, Roddy. So it has been our practice when we're reviewing recommendations for adoption to hold a public hearing and then to take action at a subsequent meeting. If anyone in our community would like to review the materials or learn more, they can use the email that we've projected above, and I will make sure to connect them with either the right resource or the right educator to get their questions answered. And now I can take some questions.
All right, why don't we go ahead and take questions in reverse alphabetical order. So Trustee Poppingay, do you have any questions or comments?
Yeah, just one quick question. Since this is largely apparently online based, does that mean that it's updated on a regular basis? Presumably it's not like buying a textbook that winds up being 5, 6, 7 years out of date.
Yes, our understanding is that the publishers are able to be a lot more nimble with what they upload or even correct as science, updates itself. The other thing to note is that it's available in Spanish for Chavez and for Montgomery, and that's one of the things that they're updating like right now to make sure that the materials are parallel, but that the instruction can happen in Spanish.
And do you have to pay for the upgrades, or is that included in the initial?
No, any adoption that you purchase is good for the term of 8 years, and the traditional experience was that meant you got workbooks for all of your students for 8 years. In an online format, that means that you have access to the digital materials updated for that 8-year span.
Thank you.
All right, Trustee Fernandez. Do you have any questions or comments?
No questions. Thank you.
Trustee D'Annunzio.
Yeah, just one question. We sort of lived this with the pilot program at Emerson and Da Vinci Junior High this year. Sort of the big takeaways in terms of our expectation for the impact it's going to have on our students' learning going forward.
I think that the big takeaway is it makes it so that our teachers are not having to do teacher created materials in order to get to the next generation science standards. It's really difficult for me to even articulate the huge shift in both what the standards held and in the pedagogy. And so this lends itself, I think, specific to Emerson and to that junior high age, what our teachers were telling us is for students to be able to do actual labs, to engage in the inquiry-based experience and to practice the engineering practices and the scientific practices was huge for both engagement and their ability to differentiate. The other thing that they've really spoken articulately to is being able to teach students the language of the discipline. So to use vocabulary and to speak like scientists and ask questions in that format is really supported by this methodology.
And just one follow-up on that. So in addition to the curriculum, there are professional development modules. What, how do we ensure that we sort of, broad, consistent application across our instructors?
Yeah, that came out as a really high priority. Actually, on the when they were speaking about the teacher rubric, one of the things that they did to assess was like what level of support and how user-friendly would it be to new teachers that they were onboarding. But the other thing that came out of that conversation, especially during the consensus meeting, was a pretty deep desire to calibrate with each other which units of study they're going to do for how long in what order, so that they could use each other as teaching partners. The other thing that's important to say is that Kim McKim and Ingrid Salim were able to negotiate professional development that comes with the adoption in the future at zero cost to us, other than compensating teachers for their time if needed. And it's important to say that Scott Richardson and Ingrid Salim are considered SASP. I forget what the technical term is, but they've been trained to train teachers on next generation science standards through the Sacramento Area Science Project.
Great, thank you.
All right, Trustee Adams?
Yeah, so thank you, and appreciate all the hard work. One thing I noticed in middle school, the program is an integrated one versus discipline specific. Could you explain how you came to the decision to actually go with an integrated versus discipline specific?
You know, I'm wishing that I could remember. I think it was about 5 years ago. I know that decision was reached, actually, I'm going to say about the same time the standards came out, because in 2013, when we were engaging in that, at the time, I believe it was Clark Bryant, in collaboration with Ingrid and the science teachers, made a deliberate decision to move forward with an integrated model. At Davis Senior High School, they are not integrated yet. And so that's actually the work of our future, is to engage in a lot of professional development 9 through 12 to decide whether that changes program.
Right. So one of the issues in adopting this program is, one, we're confirming our integrated approach at middle school, but then we will also have to get our high school science teachers to understand what the approach was in middle school, and some of the things that their kids will have different knowledge and a different approach to science, right?
Yeah, I both agree, and I think the approach to science will be using the next gen science standards, the pedagogy and the practices. The real challenge is identifying the content that students get 7 through 8. And from what I understand about the high school courses, the question before us is how we integrate earth science into the existing courses, or even lean into the idea of a 3-course model that the UCs are asking us to consider. And, you know, I did some checking around with our peers, and many of the high schools are hesitant to do that big of a shift because of the number of honors AP courses, specific courses to different trajectories. But it's an important question now that we're moving that way in the junior high, to think about a vertical articulation.
Right, regardless of whether we remain discipline specific or go to an integrated approach, there has to be some articulation. So the my other area of interest is the study of climate change and global warming. How do these materials address that?
You know, I know that I saw an Amplify. Ingrid Salim and I were discussing it specifically because it was California specific standards, and California has specifically called that out. I don't think I can speak to it credibly with the junior high curriculum, but could circle back to you.
Right, but for Davis parents who and our Davis students are concerned about these issues, it won't be put off in a different area where they have to learn it separately from science. They actually get to understand the science of those climate change and global warming.
True.
Right. Okay. All right. Thank you.
All right, I just have one question, and well, I guess a comment first is, again, you know, just the work that went into it is greatly appreciated, and obviously this is a big undertaking. But my question is, we've been talking about ethnic studies and how either, you know, we've been throwing around different models of it, but one model of ethnic studies is that it's kind of embedded in all of our courses, or you know, a subset of our courses. And so my question is, how might ethnic studies be complement, or how could it be incorporated into these new materials?
Robbie, did you want to take that, or do you want me to take a swing first?
Go for it. I have some thoughts, but take a swing.
I actually don't think I understand the content standards of what our science teachers are doing with enough depth to tell you where there are some automatic connection points. The part that I keep thinking about is that our science teachers have spent so much energy discussing different perspectives for like how scientists literally have like a world perspective, and they think about how one action has an impact that is bigger than what happens in their community. But I don't think I can give you a skillful answer without better understanding the content that each teacher is getting to.
I think it's a really interesting question, Trustee Pickett. The two domains that this kind of surfaces in my own brain, and we still have quite a bit of a journey to embark on with ethnic studies and with NGSS post the adoption. But one is pedagogical, that, and as Troy alluded to, and in NGS, you're scaffolded and supported to think like a scientist, to rely on inquiry as kind of a mode of discovery and of constructing new knowledge. And that's a very similar construct that applies to ethnic studies as well. There's a pedagogical foundation in asking questions and being able to understand the impact of various variables. So I think the approach in terms of learning science is similar, and there's an opportunity for collaboration. I don't know what that would look like, but in terms of the spirit of the instructional approach. And then the second is there's a strong focus on application and impact. So in NGSS, at a high level, not only are you looking for these cross-cutting themes, it's what they call the 3D, kind of the core pillars of NGSS. But you're also understanding application, impact, and in the broader, well, I guess that's it, the broader application of these scientific principles in the world around us across the curricula. And so in ethnic studies, again, I think philosophically, there's a similar approach. But there's plenty of room for exploration and to see, what it might look like to understand NGSS and its impact, scientific impact on certain demographics, on equity, and in the social human condition. So that's a really, really high level kind of knee-jerk response, but I think there's room for us to get creative in the way we better integrate, these fields as they emerge, NGSS, ethnic studies, and others.
Yeah, I mean, I'm thinking of kind of an example of looking at the water conditions in Flint, Michigan, right? So that's a case where there's, it's affecting a particular segment of the population, but then it was, you can use that as an example when you're studying, doing, again, speaking to that application of, let's apply it to a specific, situation that would probably, I think, engage certain students. So if those examples are something where they can imagine that they, that seem more relevant, then I think that builds in, greater engagement and makes the whole science classroom not just this, philosophical or theoretical, conceptual, study, but also something that's really kind of concrete and meaningful to their own personal experience.
I'm so glad. Sorry. No, I'm very glad that you said that, because one of the things that the teachers pointed out to me was that the strength behind both adoptions was that they both hold a storyline for students, so that instead of scientific fact and practices that are out of context, they generally present a real life, if possible, scenario and story for students to get curious about, both scientifically and the application of the impact on the scientific community or the greater community. So I see great promise there.
And I think in general, as we move forward with whenever we're doing anything new, so, coming up with new CTE offerings, or, that we kind of, if we dovetail it, then we can maybe, with ethnic studies, we can, those might be points where it's easier to integrate. So because you're building from the ground up, or they're already learning something new, so it's easier to incorporate then. So I was just thinking we should keep that as a, in our minds as we develop any sort of new courses or programs or adopt new materials.
So could I jump in here just based upon the experience of my old job? So California instructional materials actually do have to show ethnically diverse people in different categories. It's by law. And then the science framework actually does have an access and equity chapter that does require these things, probably not to the extent that we've been thinking about now. And I think you're right to call out certain areas that might examples of where science can be applied in different situations that will draw the attention of the student that might not be there. But it's not without it, but I think we can definitely enrich it. So, but that's a good point. I really liked it.
Thank you. Thank you for adding that information, Tom. That's very useful. All right, so that's the only question I had. Are there any public comments? I didn't see any for this item. Maybe Superintendent.
No public comment on this item.
Okay, so there isn't, this is not an action item, and again, it will return to us. So we'll go on to our next item, which is item 6B, trustee vacancy timeline, application, and related materials.